this video, we're going to take a look at how to graph and find the standard rule for an ellipse. So first, let's take a look at what is an ellipse. An ellipse. An ellipse looks like the following, and here's how it's constructed. You have two focus points, F1 and F2, as you see here. And these two focus points are created, and then you have what would be a string. And this string is traced so that it always stays the same distance. So this point right here is the same distance when you add these two segments. It'll equal the same distance as when you add the two segments from the purple line. The same thing with the green line. The green line will have the same distance as the purple. Even if you go way over here, it would still be the same string that would connect the foci to that point. So the definition of an ellipse is a set of all points in a plane, the sum of whose distances from two fixed points is constant. So that distance will always be the same. Okay? And there's a proof of how to get the rule from this. We're not going to go into how the rule comes about, but I just wanted you to understand what the definition of an ellipse is. So they stay equidistant. A lot of planets orbits in an elliptical pattern. They basically get really close to, of course, like the sun, and then they swing far away. But what's interesting is there's two focal points that they actually rotate around, and they stay equidistant to. The sum of the distances to those points is equidistant. So the couple of pictures to see here. Your ellipse could be oriented horizontally or vertically. As you see on the left, it's horizontal. On the right, it's vertical. Either way, there are two axes. This is the segment connecting the foci, because the foci will always be on the major axis. So the foci might be somewhere in there, just like you've seen the previous. Okay? The midpoint of the segment connecting them, this middle point, this black point that was in the middle, is called the center of the ellipse. Okay? Another way we can find it is by connecting the center going in both directions. So these 2 points here don't have a special name, but the points on the purple actually do. So these are called your vertices, okay, of your ellipse, and this is the center of the ellipse. These points will be crucial in graphing, but they will not have a special name. They will be crucial in graphing, though. So let's take a look at what the rule looks like for an ellipse that's just centered at the center of the coordinate plane. So here are two ellipses centered at the center of the coordinate plane. One is horizontally oriented and one is vertically oriented. But either way, the rule is always x squared over some number squared plus y squared over some number squared equals 1. So that 1 is key here. It's going to distinguish it between a circle and an ellipse. So we're going to look at distinguishing between them later on in this unit. A is always the length of the major axis, which is why in this first rule, A is underneath the x, because the major axis in this graph down here is on the x-axis. It's in the x direction horizontally. When the major axis is a vertical axis, the A, or larger value, will be underneath the y. So that's going to help me decide the orientation, which number is bigger. So when the bigger number is under x, I'm going to have a horizontal ellipse. When the bigger number is under y, then it's going to be a vertical ellipse. Here's the key, though. The foci will always be found using the relationship a squared minus b squared. So it will always be the difference between those two values that appear in the denominator in the rule for the ellipse. So let's take a look at this in action. So let's take a look at some examples to help us understand this better. So we have the example of graph and locate the foci. So first of all, I noticed that it's not written in standard form. So the only way to do this is to write it in standard form. So our first step is to make it look like what we see over here. And what I see on the standard form here is that I have to have the equation equal to 1. So that's key. So if I want the equation equal to 1, I need to divide everything over here by 36. on left and right. Because then I'll get the 1 on the right-hand side. So I'm going to get 1 equals, well, 9x squared over 36. This will give me x squared over 4. Plus 4y squared over 36 will give me y squared over 9. I'm dividing every single thing by 36. And then I start to see the standard form. So it looks like I'm going to rewrite this one more time as x squared over 2 squared plus y squared over 3 squared equals 1. The 2 and 3 are crucial because they're going to help me graph the ellipse. So I see that y is going to be my major axis. So that's going to be my a value in this case. So what that means for me is that my a value for vertical oriented ellipse is going to have a distance of 3 here. So just like when we graph the circle, we graph 4 key points after finding the center. Same thing here, but we have to know which direction is the bigger one. So in this case, we're going to go up 3 to find our point, and from the center, we'll go down 3. And that's going to be the ends of our major axis, or our vertices of our graph. And the same thing with the y direction, the x direction. But in this case, it's 2, because my minor axis is only a distance of 2 in both directions. So let's see, make sure that's 2. My graph starts to emerge here. So at this point, I could connect them and make my elliptical shape. Have my 4 key points. The only other 2 key points that you're going to need when you're finding the graph of an ellipse is locating the foci, the focus points, the focal points. So we're going to find those by using this fact here, a squared minus b squared. So we're going to go back up to this 9 and 4, and we're going to use these, 9 minus 4. That will equal c squared every single time. That will give you your distance to your focus points. So 5 equals c squared, or square root of 5 equals c. So that means my focal points are square root of 5 units away from the center, and they're always on the major axis. So I'm going to go square root of 5 away. Well, square root of 5 is just a little bit bigger than 2, so they're going to be right about here. And I make sure that that looks right. The more circular your graph, the closer your focal points are to the center of the circle. The more circular your graph, the closer they are to the center. Okay? The more elliptical, your focal points will be closer to the edge. So here we have our focal points. And the way we'll denote their coordinates is the focal points F1 would be at, let's see, so think about what's happening here. X is 0, y is square root of 5. And the other one is 0, negative square root of 5. Because it was that many units from the center, which is at 0, 0. So that's the basics on graphing an ellipse that has not been translated. So we haven't shifted this at all. But sometimes we will have a translated ellipse. Let's look at one more example before we look at that situation. So our next example is looking at the standard equation of the ellipse pictured here. So we know our standard equation is x squared over a squared, y squared over b squared equals 1. So I need to figure out what the x and the y, what the a and the b values are. In this case, it looks like my major axis is in the y direction, and it has a distance of 4. So that means my y, the value under my y squared is going to be 4 squared, or 16. My value under my x will be the length of the other axis. In this case, it's a length of 2 away from the center. So it's going to be x squared over 2 squared, or x squared over 4. Here is my rule. And you're done. That's all you got to do. So finding the major and minor axes, but what direction the axes are will relate to which value goes underneath. So it all should logically make sense. So now we're going to take a look at the shifting. And this is the part that you're going to add to your notes that you created on your yellow booklet for this conic sections chapter. So we're going to add these labels to our notes. This is the horizontally oriented, and so everything will fit for vertically oriented, but it'll just change x's and y's and who gets changed. So everything should fit with what you already know. So let's take a look at, first of all, what happens to the rule. So the first thing we want to understand is what happens to the rule. And here's what you want to write down for the rule. The rule of an ellipse that has been shifted is x minus h squared over a squared plus y minus k squared over b squared equals 1. So once again, h and k denote the center. So when we shift it, we're going to look just at the center to see how much it's been shifted, and that's going to be our h and k values in our rule. Okay, in our case, A is going to denote the horizontal axis, and B will denote the vertical axis. So the question is, how do we get the rest of these points? Well, we get the rest of these points by thinking about how far away it would be. So let's take a look at the vertices first, these red points that you see here, the vertex at each end of the axis. So if this is at HK, then this is A units away because of this value in my rule. So if it's A units away, that's A units away from H. So this vertex is at H plus A, comma K. That's how many units away. It's all about distance. And then, of course, I should be more careful because it's actually A units to the left, so it's H minus A, comma K. So H minus A. The other vertex is H plus A because it's to the right. So your horizontal shift will affect where your new vertexes are going to be. The focal points are always going to be c squared will equal a squared minus b squared. It'll always be the difference of the two values. Okay, since they're on the x, in the x direction, they're still going to be at level k, but they're going to be at h plus c and h minus c. So you always are going to have to go about finding that value c. But they'll be at level k because of the fact that we've shifted it up k. And so you will have to find this value c. Okay, this is key for your focal points. So this you'll want to add to your foci. Okay, under your foci, under that word on your notes sheet, you'll want to add that you always find it by finding c. Okay, and that c is the distance from the center to the foci along the major axis. Okay, so that's how far away these will be from the center. And that's the notes you'll need for foci. The next one that we're going to take a look at, we're going to label these two axes. This would be the minor axis because it's smaller. And the other one would be the major axis. So those are the main key points. This is a horizontally oriented. Everything works vertically. It just would affect now the k values. So notice that the k values all along that major axis, the k value appears over and over again. Okay, to find these points, these would be affected by the h value would stay the same, but the k value would shift up or down according to b. So it would be k minus b and k plus b. Those green points there don't have a key term. They are just the ends of the minor axis that will also be on the ellipse. So let's take a look at some examples when we've shifted the ellipse. Let's take a look first at graphing. So let's take a look at the graph. So we always start with finding the center just like a circle. So we're going to go to -2, 1. The center is at -2, 1. Because, remember, it's the opposite of what you see here. So that's my center. Now I want to think of this 9 as 3 squared and this 4 as 2 squared so that I can truly see the values of the minor and major axis. So now I can see that the major axis is horizontal. So from here, my major axis will end 3 units later. So I'm going to go 3 units to the left and 3 units to the right. Those are my vertices. Now my vertical distance is 2 and 2 because of the value underneath the y. The next thing that is going to be important to find is the foci, but I can draw my ellipse without seeing where they are right now because I'm just drawing a sketch of what it will look like. So there's my ellipse. The foci, you always start with finding the difference between these values. So remember the values were 9 and 4. And you always do bigger minus smaller. So 9 minus 4 is equal to 5. But that's c squared, so really my c value is the square root of 5. So what that means, remember, is that from the center we go square root of 5 units to the right, and we go square root of 5 units to the left. So I'm already at negative 2 comma 1. So I'm going to shift that negative 2 for square root of 5 units to the right, and I'm going to shift negative 2 square root of 5 units to the left. And those are my two foci, because they're square root of 5 in both directions. Now, if you wanted to get decimals to verify that this makes sense, then plug in square root of 5 in your calculator. Make sure that this decimal fits what you see in your graph here. They should fit with these points that you see here. Okay? Those are your foci. Where are the vertices? So the vertices are at, let's see, according to our picture, it looks like it's at 1 comma 1. That's this vertice. And then this one is at negative 5 comma 1. And the endpoints of the minor axis, I'll just label that E. The endpoints of the minor axis are at negative 2, 3. And negative 2, negative 1. And those are the key points. We're going to do one more example, and then you'll get to your checkpoints. So the last example here is kind of going backwards, but I'm going to tell you the graph is your friend here whenever you get stuck. So we use the information and we start with the graph, take a look at it, see what clues we can gather from it. So the goal is to write the equation and find the center and endpoints using the vertices and foci that they give us. So I'm going to start by graphing it. Negative 1, negative 3. Negative 1, 5. Those are my endpoints. My foci, negative 1, negative 1. And negative 1, 3. So I'm starting to see my ellipse here. Okay, this right here is my major axis. Okay, that's my major axis because those are the vertices. Okay, that's my major axis. So right now I can start to see my rule. Oh wait, I think I've got a shift here, so I got to make sure I include my shift. So my rule is x minus something squared all over something. X minus, y minus something squared all over something else squared. So let's see. Let's start with finding my center, because that's going to give me an idea. Let's see. The center seems to be right here. This is where your midpoint formula comes in handy. The center is always in the middle of the foci or in the middle of the vertices. So if you want to find the center, you can find it by averaging those points, or if you made a graph, it looks like I can see it on the graph. The center is at negative 1, 1. So that means my rule is going to be x plus 1, y minus 1. So I have two pieces to my puzzle. I also see my major axis is 4 units long in both directions. So that means the value under the y, because y is the major axis, will be 4 squared, or 16. So the last thing that I need to gather is what is the b squared? What is this value right here? And from this picture, I have no information that seems to be helpful. But the one piece of information you have is that to find the foci, it's always c squared equals a squared minus b squared. Okay? In this case, a squared is 4 squared because it's the larger axis. I also have my foci. I know that they are 2 units from the center. So that means that c is 2 and c squared is 2 squared. So I have the following information. And from this, I can find b squared. So it looks like 4 equals 16 minus something. So that something b squared must be 12. So from that information, I know b squared equals 12. And of course I could solve and work that out to figure that information out in another way. So b squared equals 12. So I have my b squared, and I can put it in my rule. Okay, it's not 12 squared, it's b squared equals 12, so my value under there is 12. So the actual distance that I would have here would be square root of 12, which is just a little bit, just under 4, it's about 3.5-ish. So that means that my distance here is about 3.5. So this is my ellipse. If I was asked to finish drawing it, it would look something like this. It's almost circular. The goal wasn't to draw them, it was to find the center and the endpoints of the minor axis. So I have the rule, I have the center is at -1, 1. And to find the ends of the minor axis, I need to go from -1, 1, and I need to go square root of 12 to the right and square root of 12 to the left. So that means my two rules will be -1 minus square root of 12, comma 1, and -1 plus square root of 12, comma 1. Square root of 12 to the left and square root of 12 to the right. So there are the pieces of information being asked here. So give these problems a try on your checkpoints in the next slide here. So in these checkpoints, you're asked to graph and find those major important points, and then see if you can write the standard rule for the ellipse with that information. Okay? Do your best, bring your questions into class, and we'll go over them at the start.